Like any other variable, before we can make use of a two-dimensional array, we need to declare and define it. The next section deals with various styles of declaring and defining a two-dimensional array. Two-dimensional array declaration requires the following four elements to be declared: the name of the array, the data type of the values to be stored in the array, and the number of rows and columns of the array. Following is the general syntax of declaring a two-dimensional array. Array name is the user-chooser name of the array. It should be a valid identifier name. Conventions and rules governing the names of identifiers have been discussed in the video on variables. You may refer to it. Num rows and num calls are the number of rows and columns in the two-dimensional array, and data type is the data type of elements the array is expected to hold. It is important to note that the first set of square brackets followed by the array name define the number of rows, and the second set of square brackets define the number of columns. For example, in order to declare an array which is expected to hold integer type values having 3 rows and 4 columns, the following syntax is to be adopted, where my array is the name of the array. Some of the 4 elements of array declaration may become optional depending upon the scope in which the array is being declared. The concept of scopes has been discussed at length in the videos on variables. While declaring a two-dimensional array in file scope, data type as well as num rows are optional. If not specified, the compiler assumes data type as integer and num rows as 1, whereas num calls is compulsory, without which the program will not compile. In general, it is always a good practice to define everything explicitly and do not let the compiler do it for you. On the other hand, if declared in a block scope, data type, num rows as well as num calls all have to be specified, otherwise the program will not compile. For example, this statement is valid in file scope and will successfully declare a two-dimensional integer type array having 1 row and 4 columns. But the same statement will not compile in block scope unless the data type and number of rows are explicitly defined. This is the modified version of this declaration statement, which will get compiled in block scope too. Expressions can also be used in place of num rows and num calls, but the expression should be evaluated to integers. We already know that irrespective of the context. The file scope allows only constant expressions, whereas a block scope allows non-constant expressions as well. Therefore, if you are using an expression to define any or both of the dimensions of the array in a file scope, the expression should be a constant expression evaluating to a integer value. On the other hand, if you are using expressions to define any or both of the array dimensions in a block scope, the expressions need to be a constant expression, but it should evaluate to an integer type. For example, this statement will not compile in file scope because non-constant expressions are used to define the array dimension, but it will compile without an error in the block scope and will define an integer type two-dimensional array having 3 rows and 6 columns. Please refer to the video on expressions for a better understanding of constant and non-constant expressions. Like every other variable including one-dimensional arrays, you can initialize a two-dimensional array while declaring it. We will look into this concept in a short while. But before that, we need to understand the mechanism of accessing individual array elements. This will be required during the upcoming discussions. Like one-dimensional array, two-dimensional array can be accessed by making use of array subscript operators. The element in the ith row and jth column of a two-dimensional array can be accessed through the following statement. It is to be noted that arrays one-dimensional as well as two-dimensionals follow zero-based indexing. Consider this example for better understanding. This statement declares a float type two-dimensional array having 4 rows and 5 columns, and this diagram conceptually represents the array declared by the statement. My array 1 2 will get you the element at the second row and third column, whereas my array 3 4 will get you the element at the fourth row and the fifth column. Having understood the syntax of accessing the elements of a two-dimensional array, we can resume our discussion on its declaration with initialization. Before we discuss the format of declaration along with initialization, we need to quickly recapitulate some important points related to declaration, definition and initialization. These concepts were discussed in detail in the video about variables. You can refer to it if required. In that video, it was stated that declaration and definition are two different things. In general, declaration is a way of telling the compiler that the declared entity may appear somewhere after the point it is declared at. Merely declaring a variable does not get memory allocated for it. Definition, on the other hand, is one step beyond declaration. Definition not only implicitly involves declaration, but it also makes the compiler allocate memory for the variable. In the same video, it was also argued that declaration without initialization is just declaration in the file scope, but in a block scope, declaration statements amount to definition. Now the most important point, when you declare and define a variable simultaneously, it amounts to definition irrespective of the scope. Keep these points in mind while we discuss the declaration of two-dimensional arrays along with their initialization. Similar to one-dimensional arrays, two-dimensional arrays can also be initialized while declaring them. This is the general format for initialization while declaration. The left-hand side of this statement has four elements: data type, array name, and the number of rows and columns of the two-dimensional array. All these elements have already been discussed in the previous section. The right side is new, which consists of a set of initializer elements separated by comma and contained in a pair of curly brackets. This syntax will define an array with given specifications and will initiate the array cells by making use of the given initializer elements. The first initializer element is assigned to the first cell in the first row. The second initializer element is assigned to the second cell in the first row, and so on. When all the cells in the first row have been assigned an initializer value, the initialization process continues from the first cell of the second row. This process continues till all the cells of the two-dimensional array have been assigned an initializer value. For example, this statement declares and initializes a float type two-dimensional array having 2 rows and 3 columns. And this is the conceptual representation of the array after it has been created in the memory. Few important points about this style of two-dimensional array declaration along with initialization should be noted. While declaring a two-dimensional array along with initialization, you may need not specify the number of rows. The number of columns still needs to be specified explicitly. The compiler automatically works out the number of rows from the provided number of columns and the number of initializer elements. For example, the previous statement can also be rewritten as this. There are 6 initializer elements and 3 columns, which implies 2 rows per column. And the compiler will create a two-dimensional array having 2 rows and 3 columns as per the previous calculation. But it is not a good practice to let the compiler define things for you. Whenever possible, you should explicitly define entities used in your programs. The data type of the initializer element should match with the declared data type of arrays. Otherwise, the initializer elements will be implicitly typecasted into the data type of arrays before getting assigned to the cells. The floating type initializer elements will be casted into integer types before getting assigned to the cells of the array. 2, 4, 3 and 1 are the typecasted values that will be assigned to the cells of the two-dimensional array. Similar to one-dimensional array, the initializer elements can be even expressions. An important point about expressions and scope should be reiterated. File scope allows only constant expressions, whereas block scope allows for non-constant expressions as well. That is why this piece of code will not compile in file scope but will compile without a hitch in the block scope. On the other hand, these statements will compile in either of the two scopes. Please refer to the video on expressions for a better understanding of constant and non-constant expressions. You should also understand and note down certain non-routine aspects of this style of two-dimensional array declaration and initialization. This understanding will help you avoid inadvertent bugs in your code. What happens if the number of initializer elements do not match the capacity of the declared 2D array? Starting from the first element, only the required number of initializer elements will be picked and the remaining initializer elements will be discarded. Let us understand this through a couple of examples. Consider this program. The number of initializer element, which is 10, is more than the cell in the array, which is only 6. The two nested for loops print the contents of the created array. It is evident from the output that only the first 6 elements are picked for initialization. What happens if the initializer elements are less than the number of elements in the array? In this case, all the initializer elements will be used for initializing as many cells as can be initialized by using the provided initializer elements. The remaining cells will be initialized with 0. The order of initializing the cells will remain the same as discussed before. See this program. The number of initializer element is 2. which is 4 less than the number of cells in the array, which is 6, and hence the first 2 cells are initialized with the given initializer elements and the last 4 cells are initialized with 0. This can be verified from the output of this program. As discussed before, that the first initializer element is assigned to the first cell of the first row and the second initializer element is assigned to the second cell of the first row, and so on. There is a mechanism by which you can modify this default order of assigning initializer elements to the cells of the two-dimensional array. By making use of additional pair of curly brackets around a set of initializer elements, you can assign a specific set of elements to specific rows of the array. Let us consider a few examples to understand this mechanism. In this statement, the initializer elements contained in the inner pair of curly brackets will be assigned to the first row of the array, which means that 1 and 2 will be assigned to the first and second cells of the first row, whereas the third cell will be initialized with 0 because the inner pair of curly brackets does not have a third initializer element. Starting from 3, the remaining initializer elements will be assigned as per the rules discussed before, which means 3 will be assigned to the first cell of the second row and so on. In this statement, the elements of the first inner pair of curly brackets will be assigned to the first row and the third element will be initialized with 0. And the elements of the second inner pair of curly brackets will be assigned to the second row. The remaining initializer elements will be used for initializing the cells of the remaining rows, and this is the conceptual representation of the two-dimensional array created by this statement. Consider for 2 more examples. This statement declares and initializes a two-dimension array. Also see the conceptual representation. This statement 2 declares and initializes a two-dimensional array. Also see the conceptual representation. You need to be careful with the placement of the curly brackets, otherwise you may end up getting weird results.